Welcome back, Manaswini.
Good afternoon, sir.
Invite your old friends also to join. Okay, students. So now continuing the what we were talking about, and I'm sharing you one video that will describe you how really in lab we perform our quantification using spectroscopy or spectrometry. And please let me know if voice of the video is audible to you. Is voice of video is audible to you all?
Yes, sir. Yes.
Please now I'm continuing it. To quantify DNA. In this activity, the amount of DNA in the purified plasmid preparation will be estimated using a spectrophotometer. Approximately 10 minutes before starting the experiment, turn on the spectrophotometer so that it has time to warm up. You will need two cuvettes that are transparent to UV light. When handling the cuvettes, always place your fingers on the opaque side and not on the transparent surfaces of the cuvette. Label one of the cuvettes C for control, and the other cuvette will be your test. Set your micropipette to 245 microliters.
microliters of distilled water into both cuvettes. Set your micropipette to 5 microliters. Pipette 5 microliters of purified DNA sample into the test cuvette. Pipette up and down to mix the sample. Set the spectrophotometer to its DNA quantification setting. Your screen should show that you have selected for DNA. Press the Enter button. Press the Enter button. The display screen should now show that you are ready to read absorbance. Press the right arrow button. Insert the control cuvette, making sure the correct side is facing forward. Press the Read Blank button. After completing this process, the screen should read 0 absorbance. Remove the control cuvette and insert the test cuvette with the DNA sample. Press the Read Sample button and then hit the right arrow. When finished, the display will show that the absorbance is 0.011 and the concentration is 0.5415 micrograms per milliliter. The original dilution was 50 to 1, so you will have to multiply it by 50 to get the final concentration. To get the purity, press the 260 to 280 ratio. The result here is 5.4921. Anything greater than 1.8 is pure DNA. Therefore, in this case, we have determined that we have purified plasma. In this video, you will learn how to use an adjustable micropipette. Micropipettes are one of the most commonly used tools in the molecular biology laboratory. An adjustable micropipette is used to measure and transfer small volumes of liquid. The parts of a micropipette include the plunger button used to fill and dispense samples, the tip ejector button used to remove used tips, the volume adjustment knob used to adjust the volume you wish to transfer, the digital display window displays the volume being selected, the shaft, and the ejector arm, which ejects used tips, and a disposable pipette tip. The volume range for a micropipette can be found at the top of the plunger.
So students, you have watched, I think, video dedicatedly. So I think video clarified everything, every step of your spectrophotometry and how to perform the quantification. And the spectrophotometer they showed is of bio-red. As I mentioned you about Sparky Elmar and Pyred is also the one which is supplying the spectrophotometer. And some spectrophotometers are providing you the specific specific things, like you want to quantify protein, you want to quantify DNA, so on. So in that they show you setting for DNA, so that you can have the radiation wavelength for both 260 and 280, and also you can go for the purity, like the ratio you need. Okay, so now it's over to you. If you have any queries regarding this experiment, because here I'm showing you the virtually, so when we are really going to be in the lab, so hope news are coming that after 16 campus may open. So there May is there. So I can't assure you that this will be open or not. And if it's going to be opening, then we may come to the lab also and can do some of the experiment. So meanwhile, platform is open for discussion. So you can ask whatever question you feel, whatever things are coming in your mind regarding what we have discussed today, including both first experiment, second experiment, and also your theory part. Okay, so one by one, starting from the Adish. Adish,
Present.
I am not taking attendance. सो गए थे क्या?
नहीं सर.
तो फिर वही 3 इडियट वाला काम करते कि बोलते हैं कंटिन्यूस सर.
नहीं सर. सर आपकी आवाज के साथ बैकग्राउंड में कुछ आवाज आ रही है, इसलिए क्लियर नहीं हो रहा था, इसीलिए बोल रहा.
I am asking any query regarding what we have discussed here.
सर सॉरी सर, कैन यू रिपीट?
कोई सवाल, शक, पीड़ा, शंका, समस्या, परेशानी? Any query? Ayushi?
नो सर.
Ayushi?
No, sir.
Demetrius? Demetrius? Devanshi?
No, sir.
अभी नो आने करके हम समझ सकते हैं. Okay. I gave you one assignment in the previous class about performing your experiment at your home. So how many of you performed that?
Sir, I'm currently living in a hotel, so I don't have a kitchen, so I was not able to do it.
Okay, so why you staying at hotel?
Um, oh, kind of a long story, sir, but US में हूँ अभी तो थोड़ा.
वो तो पता है यूएस में हो, लेकिन यूएस में तो घर है ना तुम्हारा.
नहीं, वो मैं अपने शहर में नहीं हूँ सर.
गर्लफ्रेंड क्या पे है?
Sorry, sir.
चलो छोड़ो. Okay, so one question came, that is why we use and when we use quartz cuvette. Was not audible during the network. So if you have watched this video, so in this video one term they use UV transparent. So you must use UV transparent cuvettes, and the quartz cuvettes are the UV transparent one. And quartz one simply they are 100% transparent, not just to the UV, they are transparent to every wavelength. So that's why we should use quartz cuvette. More specifically, if you are working in a wavelength range of UV ultraviolet, simply means that 200 to 320%, mainly 200 to 280. So in this to 200, 300 or 20 something, if you are working this wavelength range, so in that range you must use quartz cuvette or UV transparent cuvettes. Okay. And one more question is from the Yuvraj Pradyuman. So Yuvraj wants, sir, why is necessary to wipe the fluid to clean it? Wiping is required for the cleaning. Because if you do not wipe, then the water will be over the surface of it. Then water is a good reflector also. As you can see your image in water. So if the water is going to be present on the surface of your cuvettes, then that water may serve you as a mirror and that may reflect the lights. So that's why you must wipe so that no water is there on the surface. Surface means outer surface of your cuvettes. Okay, so the reflection, to minimize the reflection, we are doing it. Okay, because if the reflection is there, so reflection will also be considered for the detector is going to read reflection also as an absorbance, because detector is reading the transmittance. So one thing, what detector is reading out? It is reading out transmittance, whatever light being transmitted. So if light is not transmitted, it means it is being absorbed for your spectrophotometer. Okay, so to avoid such type of a thing, so such type of a reflection thing that your detector may not misread that, we must clean the surface of your cuvettes, both inner surface and the outer surface, to get whatever true absorbance is there must reach to the detector. Okay, so this is the purpose why we should wipe before placing inside the spectrophotometer. Okay,
Sir,
so yes, Yuvraj.
sir, is there any range of the values which determines the purification of DNA?
As I mentioned you that your 1.8 is the one which is considered as a pure DNA. So you can say that the 1.8 to 2.2 you can consider good DNA. So if fluctuating from 2.2 away, there will be a DNA. So there will be RNA impurity. Below 1.8 is going to be protein impurity.
Sir, can you please repeat actually the voice?
1.8 to 2.2, 1.8 to 2.2 we may consider as a good DNA. Okay, above 2.2 definitely more RNA is going to be there. Below 1.8 there is going to be protein. So you may consider up to 1.6 also an acceptable one. But if you are going below 1.8, then there is a protein. Above 1.8 there is going to be RNA.
Sir,
Yes. Also turn on your camera while you are asking things, because in our discussion your camera must be on. For me also it should look like that I am talking to you, not to the left.
am I visible?
But not yet Shakti. Just now you are visible Shakti. Yes.
Sir, so my question is it important to have a blank test tube? Like, if without it, we will not be having the null reading?
It is not important, it is must. As you already you yourself mentioned that without this we can't get null reading. Yes, it's true.
Okay, sir.
Blank is must. Because we must know that what is zero. From where you have to start. If you don't know zero, then we can't say what the real value is. Turn on your mic. Your mic is off, I think, Shakti.
Oh, sorry, sir. So when we switch it on, we don't get like null reading.
See, we will get the null reading, but that null is of air.
Okay.
Okay,
Okay,
getting my
sir.
point. That null is of, see, in whenever your race is being started, so race is not being started from the home. Race is starting from a 0 point. From this point onward, you are being calculated. Runners may start running before also, but it not being counted. So being counted is from where we are going. So here is not the one. We are placing our Q8. So Q8 may also be going to have some absorbance. Then we are placing some water into it. Water may also have some absorbance. However, they are going to be transparent. We believe that they are going to be transparent, but they may have some. But in the decimals they are going to have. So that also we have to zero. That we have to make that this is zero. Whatever the readings we are going to have is of DNA only or of your sample only. So that's why we have to blank with everything that is present in your sample other than your sample of interest.
Okay, sir. Thank you.
It is must. It is not just necessary, it is must. Okay, so what next? Who is the next? Who's going to be the next? Okay, so just three questions. All of you ask a nice question, one thing. Okay, but we have further few more time. So I'm searching meanwhile some good video to show you. So this is going to be a nice one. So it is going to be explain you. It is going to be explain you some spectrophotometer expect your abuse spectra also. So I'm sharing you. Please enjoy that also.
We will see about DNA quantification using UV spectrophotometer. DNA is quantified in terms of weight by volume of sample. After purification of DNA, it is generally resuspended in DE buffer or deionized distilled water, and hence the quantity is measured in the unit weight by volume, either microgram per ml or nanogram per microliter. There are different kinds of DNA samples are made to be quantified, such as genomic DNA with very large size and plasmid DNA, PCR products, restriction resistant DNA, single stranded DNA, small oligomer DNA. Accurate or near accurate quantity of DNA is necessary to perform several molecular biology. And how much restrictions in DNA present in the reaction is necessary. So it is represented at number of base pairs. In general, two methods are followed for quantifying the DNA concentration. First one is spectrophotometry. It is machine based and it will take relatively less time. Another method is called Agarwal-Chen electrophoresis. It is a classical method. We can visualize the DNA quality along with calculating the quantity. In this video, we will see about the spectrophotometry method of quantifying DNA. Generally, the nucleic acids, including DNA or RNA, absorb the ultraviolet lights in a wavelength of 260 nanometer. And we know 200 to 400 nanometer lights are ultraviolet wavelengths. When we check the absorbance capacity of DNA under UV light at different wavelengths, the DNA molecule absorb high quantity of light at 260 nanometer compared to other wavelengths. And the capacity to absorb light at 260 nanometer by nucleic acid is 1.8 times higher than its 230 nanometer light absorbance and 280 nanometers light absorbance. So this criteria are considered while quantifying the DNA concentration. Next, we will see how to quantify DNA using spectrophotometry DNA absorbance.
So this is the spectra that I was referring you. So as you can say, this is spectra of your DNA. So it is absorbing maximally at 260. It also absorbing at 280. So this ratio of these two absorbance, so that is at 260 and 280 is going to be constant. Whatever curve height is going to be there. So if it is turning like this, and it will be like that. So sorry. So this ratio is going to be constant. So that's I was referring you.
So this criteria are considered while using spectrophotometry and its basic principles. The nucleic acids absorbs maximum light at 260 nanometer, and according to Pierce and Lambert law, the absorbance depends on the concentration of the DNA and length of the light traveled in the solution. At a constant 260 nanometer wavelength, make the light to travel 1 centimeter of the solution principle, the DNA concentration in the sample will be a variable and it helps to quantify the DNA. In UV spectral photometer, the absorption is converted into optical density value and it is connected to a computer. Computer automatically calculate and convert the optical density value into DNA quantity. A constant from a double stranded DNA present per double stranded DNA, 50 microgram of DNA per ml.
So this is the table that I was referring with the concentration. So if double stranded DNA is there, then the one OD, one absorbance reading is going to be 50 microgram, single stranded 33 microgram. Oligonucleotide, they are going to be single stranded DNA, but they are small DNA. For them it is going to be 30, and RNA is going to be 40 microgram per ml.
Concentration will absorb one optical density value. 33 microgram per ml of single stranded DNA will absorb one body value of light, and oligonucleotides absorb at the range of one body is equal to 30 microgram per ml. Similarly, RNA will absorb 40 microgram per ml for one body.
So I'm giving you one calculation with this table. So if you are taking and your sample is going to give you 0.25 absorbance reading, 0.25 unit absorbance, what is going to be the concentration of your double stranded DNA, single stranded DNA, oligonucleotide and RNA? You are going to get 0.25, 0.25 is the absorbance reading. What is going to be the concentration of your DNA sample? Simple calculation that I'm asking you, you are going to get reading of 0.25. What is going to be the concentration of your sample? These are the factor if you are having the one OD, and these are going to be your concentration. But you are not having one, you are going to have 0.25.
So 0.5 or 0.25?
0.25.
So for dsDNA it would be 12.5.
Okay. Single stranded. Or single stranded.
Sir, I'm calculating. Um, 8.25, sir, for SSDNA.
So is calculations are right? All are agreed with this calculation? कैलकुलेशन ठीक है? Yes, Yukta.
Sir, what was the answer? 8.25.
Yes, you are saying 8.25.
Yes, sir. It's the same.
Okay. Yes, these are both the calculations are right. For DNA, the reading is 0.25, then it is going to be 12.5, and for the single stranded, it is going to be 8.25. And what is going to be what is going to be considered RNA? What are going to be the concentration of your RNA? RNA की concentration क्या होगी?
Sir, what is the quantity?
Same 0.25.
No, sir, that table one.
Table you should remember. You should what? You should take notes. It is 40. 40 for RNA.
Then it would be 10, sir.
So now one more calculation you have to do. So your sample is going to give you absorbance of 0.25 at 260 nanometer and 0.2 at 280 nanometer. Tell me the purity of your sample. Your DNA sample is having absorbance 0.25 at 260 and zero point 0.2 at 280. Tell me the purity. No one is responding. DNA sample giving you absorbance 0.25 at 260 nanometer and zero point 0.2 at 280 nanometer. Please tell me the purity of your sample. Manaswini, Manaswini, yes. Tell me the purity of your sample when it is having absorbance 0.25 at 260 nanometer and zero point 0.2 at 280 nanometer. And also turn on your camera. Manaswini, turn on your camera. Okay, I think Manaswini don't want to answer. So now next to Saiba, Sahiba, 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 Sahiba. Sahiba is absent. Shakti, I will ask you later.
Sir,
Yes, Sahiba, turn on your camera.
yeah, sir.
Yes, tell me
Yes,
the
sir.
answer.
So I don't.
I have this, told you several times today. I think. Are you
No,
listening or not?
sir.
Are you listening or not? Same question is to
Listening to
Namrita.
you.
Namrita, Namrita, Namrita. Namrita is absent, I think. Okay, so now questions to Yuvraj. Yuvraj,
Yes, sir.
yes, same question to you also. Tell me the answer.
I haven't done it yet.
Turn on your camera also. Yuvraj, turn on your camera. Okay, same question is to Devanshi. Devanshi,
Yes, sir.
Yes, same question is to you also. All of you are blank. Were you listening or not? It seems that it's waste of time. My all 2 hours are waste. All efforts are waste. Everything is waste. Yes, Shakti. So now it's finally going to Shakti only. Yes, Shakti was saying something. Shakti.
Yes, sir.
Yes, you were saying something.
Sir, yes, sir. For 0.25 for 260 nanometer, it would be 65.
You are answering. Do you know what I asked for?
No, sir, I'm not sure. You asked for absorbance.
I think you are not listening what I asked. Can you repeat the question? What question I asked?
Sir, I just heard that we need to find the absorbance for 0.25 for 260 nanometer.
I didn't say it. I think you didn't listen the question also.
Sir, I don't know. Your voice is breaking. I think.
When I start asking anything, my voice start breaking. It's always happened. So whenever I'm asking anything, it start breaking to every student. Now if I ask to anyone, he will say that sir, your voice is breaking. So when you didn't listen the question and how you answered it, then you are answering without listening. And when I'm asking you, ask anything, any question, I ask any question, then you are saying no, 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 everything is clear. When everything is clear, then why you are not able to answer it? Because you are not listening at all. Even you are not listening the question, but I'm asking, and if you are, even you don't, can say that sir, please repeat the question because I have repeated question several times. So now again I'm repeating questions. So your absorbance for a DNA sample at 260 nanometer is 0.25 and at 280 nanometer is 0.2. Tell me the purity of your sample. Now question is clear. What I'm asking? Yes, Vivek. Vivek. Vivek.
Yes, sir.
Is question clear to you?
Sir, to be quite honestly, no, because your voice has been cutting in and out constantly on my end. I was not able to hear the figures or anything.
Okay, so I'm repeating question again. Now is it clear? Now voice is clear. Now voice.
Even now, sir, it's fluctuating. If you could type the question in the chat box, that would be helpful.
Okay, so I'm typing my question in the chat box.
What if I answered?
Who is I?
The Manaswini.
Okay, Manaswini, turn on your camera and answer it.
Sir, am I visible?
Yes, you are visible.
Yeah, sorry, sir. So, you've mentioned that the absorbance at 260 nanometers is 0.25 and 280 is 0.2. So, will the purity be 1.25?
What is for 1.25?
The purity of the sample.
So what do you mean by 1.25? Is not the purity.
So, you're not audible at all.
That is not the purity.
It's not okay. It's wrong.
It's wrong.
Okay.
Anyone else?
I'm not sure.
Anyone else? It is not at 266. It is. Anyone else? Yes, Vivek. Vivek. Raj, you want to say something?
Sir, it's difficult for me to do it. It would be more better if you could explain it.
Why it is difficult for you? It's so simple. Nothing difficulty is there. Anyone other than?
Sir, is it 0.9?
0.92. What is 0.05? Ishita, what is 0.05? Ishita, what is 0.05?
Am I audible?
Yes, Ishita.
Yeah.
What is 0.05?
Yeah, I'm not sure. Purity of DNA 0.05.
I'm asking you what is 0.05?
For purity.
What do you have this? Purity? Any unit is there? Okay, so now moving back to what Manaswini have answered. Manaswini mentioned that it is 1.25.
Yes, sir.
So Manaswini, what you mentioned, the 1.25, it is the ratio that you mentioned, the ratio of 260 to 80.
Yes, sir.
280, just a moment. So focus on your chat, just I'm sharing you your whiteboard. Just a moment. Okay, so as we mentioned that a ratio 260 to 80 will give you the status of the purity of your sample. If this ratio is going to be 1.8, then we'll consider sample is pure. And if this ratio is less than this, we will consider the sample is have the impurity. That impurity is of protein in nature. If this reading is more than 1.8, we will consider it have the again impure, and impurities are of RNA in nature. So as current example is giving having the 262.5, sorry 0.25, and 280 is going to be 0.2, and this ratio is going to become out 1.25. So this 1.25 is less than 1.8. So if it is less than 1.8, it means your sample is impure, and impurities are of protein in nature. So having the 260 to 80 ratio, you can tell that whether your sample is pure or impure, and if it is impure, what is the nature of impurity. Okay, is it clear now? Is it clear now?
Yes, sir.
Okay, so now we are at the end of our session, so please turn on your camera while I'll call your name. So first is Adish. Adish. Adish.
So am I visible?
Ayushi. Ayushi.
Present, sir.
Demetrius.
Present, sir.
Devanchi.
Present, sir.
Ishita.
Present, sir.
Janvi.
Present, sir.
Chitij. Kshitij.
Present, sir.
Anaswini.
Present, sir.
Amrita. Namrita.
Present, sir.
Nandini.
Present, sir.
Nandini, turn on your camera. Nandini, why you remain absent in many class? Why you were absent in previous class?
Sir, it was my supplementary exam, so I couldn't attend.
Okay, so Nehal. Nehal.
Present, sir.
Rupal.
Present, sir.
Saiba.
Present, sir.
Sanjana.
Present, sir.
Shakti.
Present, sir.
Shivani. Shivani. Tanvi.
Present. Present, sir.
Tanvi.
Present, sir.
Ridiv.
Present, sir. Present, sir.
Vivek.
Present, sir.
Yukta.
Present, sir.
And last, Yuvraj.
Present, sir.
So Athoiba is absent, rest all are present. So stay safe, stay happy. Good day.
Thank you, sir.
Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.